Hello, welcome back. I don't think I need to introduce myself because if you haven't, if you don't know who I am, please go to the previous video to this one. I don't remember the video number, 71 or 72 or 75 or whatever it is. And then you know who I am. Just in case you don't want to, my name is Osale Mohana. I'm a math teacher who has taught for over 50 years, A-level maths mainly, and I'm using these lessons to go over some of the topics of pure maths as a revision, not as a replacement of what you do in school. It's only a revision to reinforce and help you revise. Okay? Last time I showed you the link between the process of peeling an onion and function of a function. I said in the next lesson I'll take some more examples, so that's what I'm going to do now. Suppose I had y is equal to 2 over square root of x plus 1 whole squared minus 4. Ooh! So that makes life very difficult. I could make it x plus 1 power 12 minus 4. Okay, because you will say, sir, I can expand this. So I'll make it 20. So what we do is, the one way of doing it will be, I will show you, y equal to 2 over root u equal to x v power 20 minus 4 v x squared plus 1, v equal to x squared plus 1. Oh my god. So, can I write y as 2u power minus half? So, dy by du equal to 2 times minus half u power minus 3 over 2, which is minus 1 over u power 3 over 2. What is du by dv? Is 20 v power 19. What is dv by dx? 2x. So what's your dy by dx? I'll write it here so that you understand. Dy by dx will be minus 1 over u power 3 over 2 times 20 v power 19 times 2x. Your question didn't have any v or u, so you have to convert this. So that would be, so now you have seen these steps, so I can rub this off. I want to write the dy by dx here and leave it so we can cross check when I do the, so dy by dx equal to minus 40x times x squared plus 1 power 19 divided by, what is u? X squared plus 1 power 20 plus 4 power 3 over 2. You understand how many pitfalls we had? You have to identify the functions, then call each one with a letter, find the corresponding derivative, and then join them together. I started sweating, oh my god, because the air conditioner is not on. Ooh. I hope if you get some noise from the air conditioner, my apologies. I'm sweating already. So let me do it the other way. So y equal to 2 times x squared plus 1 power 20 minus 4 power half, minus half. As I said, imagine this to be an onion. One layer is power minus half. Second layer is power 20. Third layer is, how did I do it? Yeah. And then, and the third layer is that minus 4. In other words, when I am differentiating the minus half, this thing will remain the same. When I am differentiating the 20, this thing will remain the same. X squared plus 1. When I am differentiating x squared plus 1, 2x will come out. So, dy by dx equals let us differentiate the minus half. So 2 times minus half times whatever you have inside the inner core, the next layer remains the same. Okay, I did that. Now I am differentiating this. When I am differentiating this, the x squared plus 1 is another layer. So power 20 gives you anything power 19, but the minus 4 gives you 0, so I don't have to write it. Okay, and then so I have done that, I have done that, I have done that. The only thing that's left is x squared plus 1. When I differentiate x squared plus 1, I get 2x. So let us, oh sorry, I should have written here. No, not these, not these. B, I have done that, I have done that, I have done that. Now I have done that. So put a tick, so you have done everything. So 2 and 2 cancels. 20 times 2 is minus 40. X squared plus 1 power 19 over x squared plus 1 power 20 minus 4 to the power 3 over 2. I got the same answer. Life is much easier. So in other words, you need to be careful. Many students, what they do is, especially in trigonometry, I'll show you the error. What they'll do is, they'll write minus 3 over 2 times 2x. 2x power 19 or 40x power 19. No, when you are peeling one layer of the onion, the other layers remain intact inside. That is something you should remember. I'll take another example, show you how you can use the shortcut. But if you don't like it, I don't want to be involved, then please do it that way. You'll get the same marks. No harm. You will not be penalized and you won't go wrong either. Okay. So let me just rub this off now so that I have a bit more space. This is where I have seen students committing errors, which I will show you, common errors. Example 2, y equal to cos squared x. Standard answer. Sine gives you cos, cos gives you minus sine, so cos squared gives you minus sine squared. Or somebody becomes more intelligent. Oh, but minus sine squared is plus, so cos squared x gives you sine squared x. No. Whenever you have a trigonometric function with a power, please write that as, write the power in brackets. I'll show you chain rule, then I'll show you onion rule. So, by the way, onion rule is my own creation. You can't find it in any textbook. Okay? So, y equal to u squared, u equal to cos x. So, dy by dx equal to 2u and du by dx equal to minus sin x. So, dy by dx equal to minus 2u sin x, which is minus 2 cos x sin x, or minus sin 2x. Well, that's nothing big. I could do it. I would do it another way. So, there I can see somebody, yes. Double angle formula, yes, you can use that. So, or someone can say y is equal to, what the formula for cos squared x? I started with cos 2x equal to 2 cos squared x minus 1. So, cos squared x equal to cos 2x plus 1 over 2. So, dy by dx is equal to half of cos 2x gives you minus sin 2x. And your answer is, my answer is minus half sin 2x, whereas that answer is sin 2x. Who is wrong? Who is right? This is a typical wrong answer. Why? Because to differentiate cos 2x plus 1, you have to use chain rule again, because it is not enough. Cos x gives you sin x, cos 2x gives you sin 2x and something else. I mean, cos x gives you minus sin x. So, cos 2x gives you minus sin 2x and something else. So you need to be careful. You can't blindly write minus sine 2x, which is again a typical error from A-level student. Please be precise. So this is wrong. Then how do we do it? Very good. So y equal to, let me write this, y equal to half of cos 2x plus 1. So we'll say y is equal to half cos of u plus 1 and u equal to 2x. So dy by dx equal to half times minus sine u, sorry, not dy by dx, dy by du, du by dx equal to 2. So dy by dx will be, I'll just do it here. So dy by dx will be minus half sine u times 2, which is minus sine u, which is minus sine 2x, which is the answer I got. So using double angles also you can do it. Using chain rule you can do it. But I will avoid all this with my onion rule. So let me just leave the final answer there. You have seen how complicated it can be and how simple it can be when I use the onion rule. So dy by dx. I have my onion. It only has two layers. One layer, the outer layer is a square, inner layer is a cos x. When I am differentiating the square or when I am peeling the outer layer, the inner layer is not affected. So when I am differentiating the square, cos x does not change. What does anything square give you? X squared gives you 2x, y squared gives you 2y, t squared gives you 2t. So cos x whole squared gives you 2 cos x. So I have peeled the outer layer. When I differentiate cos x, I get minus sin x. So the answer is minus sin 2x. Got the answer without having to do all that? Isn't life easy? But you need to be careful because please note, as I said, the common answer here will be cos gives you minus sin, so minus sin squared x. You get a lovely, beautiful egg which you can take home and cook and have an omelette. But not marks. You'll get 0. Let me take another example. I'm just trying to show before I go to teach you product rule and quotient rule and simplification, I would like to spend another, okay, y is equal to tan cube 3x squared minus 1. Aha! Ooh! I'm not gone to second derivatives yet anyway. Now, let's use as usual. There is no formula for tan cube, no double angle, triple angle. So what we have to do? We have to use, let's say, chain rule. So y equal to t cube, t equal to tan u, u equal to 3x squared minus 1. You have to identify, you have a tan, you have a cube, you have a tan, and you have a 3x squared minus 1. The same logic applies for the onion, only you don't mention them like that. It's nothing different, nothing complicated. So dy by dt is 3t squared. dt by du is sec squared u. du by dx is 6x. So dy by dx equal to, remember, when you multiply the 3, dt is cancelled, du is cancelled, you get dy by dx. 3t squared, sec squared u, 6x. So that is 18x times tan squared u is 3x squared minus 1, sec squared 3x squared minus 1. That's the final answer. Yeah? Now, I will show you using onion rule. Remember I told you, write this as, please, tan gives you sec squared, so tan cube gives you sec power 6. Brand new method of maths. Paris, please. Okay. Tan of 3x squared minus 1, the whole cube. What is the outermost layer? Cube. Anything cube gives you 3 times the same thing squared. So 3 times tan 3x squared minus 1, the squared. I did the 3. Tan of anything gives you sec squared of the same thing. Because remember, when you've done the 3, you're left with the tan. There are two functions. The outer layer is tan, the inner layer is 3x squared minus 1. So tan gives you sec squared, 3x squared minus 1. I've done the tan. 3x squared gives you 6x. So it is 18x tan squared 3x squared minus 1 sec squared 3x squared minus 1. This way, well, you might be wondering, sir, it's going to be difficult for me to figure out how. The best way to figure out will be, imagine you are finding the value of y when x is 10. What is the first thing you do? First, you find 3 times 10 squared minus 1. That means you do 3x squared minus 1. Then you find tan of the answer. So tan of 10 squared is 100, 100, 300, tan of 299 radians, by the way, which is, you find tan of that. And then, third thing, you find tan cube. That means cube. So, look, this is the process of using the calculator. Now you are reversing because you are opening it up the other way around. So first you do the cube, in which case tan and 3x squared don't change. Next do the tan, in which case 3x squared minus 1 doesn't change. Then you do 3x squared minus 1, you get 6x. Alright, I will use this and show one more example and stop this. If it is boring, if you have understood, you can go bye-bye. Those who want to go can go. Otherwise, I will show one more example just to reiterate what I am trying to do. Y equal to sec squared cos 3x squared plus 2. Right. If I am using a calculator, what would I do? First, I do 3x squared plus 2. Then, I do the cos. Then, I do the sec. Then, I do the square. Correct? If you are using a calculator, put let's say x equal to 1. So, find 5, cos 5, then find sec of 5, and then you square it. Now, go in the reverse order. So, when I am doing square, the sec and the cos and the 3x squared remains the same. What does a square give you? A square gives you 2 times the same thing. So, sec squared gives you 2 times sec times cos of 3x squared plus 2. I have done the square. Now I have to differentiate the sec. When I am doing the sec, cos and 3x squared don't change. What does sec x give you? Sec x tan x. Sec y tan y. So, sec of this damn thing gives you sec of that and tan of that. I've done the sec. Now, I have to do cos. Cos of anything gives you minus sign of the same thing. So, minus sign 3x squared plus 2. I've done that. 3x squared plus 2 gives you 6x. You can use chain rule. If you want to use chain rule, y equal to u squared, u equal to sec v, v equal to cos u t, and t equal to 3x squared plus 2. Then please do it. You'll get the same answer using chain rule. I will write this answer. So it is minus 12 sine 3x squared minus 12x sine 3x squared plus 2. So I've done that. I've done that. I've done that. Then tan of cos of 3x squared plus 2 times sec squared of cos of 3x plus 2. Please work this out using chain rule. See if you get the answer. I could do it in one line. But as I said, if you're not happy, please use this method. Okay? See you in the next lesson. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.